Okay, this question 10, and I might as well let you know this is page 172 now, from the textbook. This type of question I'm going to call addition or subtraction of two normalized, of two floating, no, let's call it of two, of two floating point numbers. Okay, so that is the type of question we have. Learn the method for each type of question. Right, okay, so now the method is this. We're going to make the exponents the same by adjusting one floating point number. Then, that's the first one, then we can add the mantisses of both alone, right? And then, lastly, is normalize the answer. If that doesn't make sense to you, hope normalize the answer. If that doesn't make sense, hopefully when we do a question, that will. Okay, so right, so the two numbers are right, so this would be 0.1, so we know it's a positive number, by the way. I need to copy it correctly. 0, 0, 0, 0, 0, 0. That's our mantissa, and our exponent for this is going to be 1, 1, 1, 1. Okay. Right. I might as well make this clear, so that's a positive number. And then the other number is 0.1101, 0, 0, 0, with the exponent of 0, 0, 1, 1. No, 0, 0. No, there, anyway, that's right. Okay, so right, so make so the first step. Now, by the way, we can't just add these two while we're here, this is also a positive number anyway. So, right, so we need to add. Do we need to add? Yeah, we need to add these two floating point numbers. Okay. Now we can't just do column addition here. Because these exponents are different. If we do these, it will be incorrect because we're adding up the wrong column to the wrong column. Okay, so we aren't going to do that. What we're going to do is adjust one of them. Okay, so this exponent, so that's -8, and that's going to be 1, 2, 4, and so this number is going to be, doing it the one way, it's going to be -8, I'm just showing you the steps, plus 7. So this is -1. Okay, so that's it, this exponent is effectively, the adjusting is going to be 2 to the -1 for that floating point number, and then this one minus 8, 4, 2, 1, and this is going to be times 2 to the 2. Now I want to adjust, now I'm going to call these A and B. I'm going to adjust one of them to be I'm going to adjust one of these exponents to be the same, and adjust this, adjust one of those mantissas as well. And it doesn't really matter which one. So I'm going to make them both become. I'm going to adjust it to. I'm going to adjust this one to be the power. A. I'm going to adjust A to be the power 2. Okay, it's going to be adjust this one. Okay, or A. Right. So now let's think about what is required. Right. So we're doing step 1 of this method. Right. So now, let's think about the powers. So we're going to go from that is the power that we have here. We want to times it by another adjustment which we don't know. Okay, to end up at to the 2, which is that one. Okay. So we need to adjust. This is going to be our adjustment, actually. This is going to be our adjustment for this number to bring it to this exponent. So we're going to denormalize it, if you like, so that we can then add it up. Okay, so let's do it. Now, rules of indices. So we know that 2 to the minus from this, we know that plus something gives us 2. So that is going to be, that something is going to be a 3, isn't it? Okay, so we know that's 3. So let's adjust. So now we're doing step 2 here. Step 2. We are going to. This was step 1. No, this was step 1. Okay, so now we're going to add the mantis. Actually, no, we need to just make a slight adjustment. Excuse me. To this, we need to make this adjustment here. Okay. All right. So now our exponent is going to be positive 3. So that means that to take that into consideration, we need to do the opposite here. Okay. So plus 3 would make the number bigger, so we would jump, the decimal point, the binary point would jump to the right, but we need to jump to the left because we need to make it smaller. Okay, so we need to go 1, 2, 3. That is our mantissa, so let's put that here. So that's going to be 0.00011. Okay, and then that is all to the power of 2 because we made that adjustment. And now we have B, that was our number A, and now we've got our number B, and that is 0, 1, just copying it down now carefully, 0, 1, 0, I'll put these other zeros in. Okay, and that is also to the power, oops, that's also to the power 2. Okay, so just to make it clear, this is that number, no change. But this number here, same, but this is adjusted. Because we made this happen. So now they have both the same power. So now we can, the column headings for both these mantisses would be the same. So now we can add them up. So let's do that. So let's add these up. 0, 0, 1. So 1 and 1 in binary addition is 0 carry the 1. And then that's got to be 1, 1, 1, and a 0 here. And that answer would also be 2 to the 2 to the 2. Okay. Right. Okay, so all that's left is, so that was step 2, by the way. And then step 3, we need to normalize the answer. And the answer, if we had 2 positive numbers, we're going to get a positive number. And we indeed have got a positive number. Oops. We have got a positive number. So, which is actually normalized. So we don't need to make any adjustments. So our final answer is going to be that 0, 1, 1, 1, 0, 1, 0, 0. Okay, and the answer is, let me see. Yeah. Okay, so let's just check. 4 bits, 4 bits. So this is our mantissa, and then our exponent is going to be 4 bits. So that's going to be 2. So 0, 0, 1, 0. Okay, that's our exponent. And that is our final answer. Once again, leave out the binary point because that is not stored. It's assumed to be in that position for normalized floating point numbers. Okay, so quite a lot going on in that question, but I think the key thing is to note this strategy. Okay. Right. Thank you.